All right, we're looking at the candidates test here. This is a way to determine your a min and max, not just a regular local min and max, but to find the absolute min and max. So if it asks for absolute min and max on a specific interval, this is what you're going to have to do. So first off, when it asks for an absolute maximum or an absolute minimum, or in this case both, they specifically are asking what is the y value? What is the biggest value that occurs, or what is the smallest function value that occurs in this problem. So, like all max and min, we begin by having to take a derivative. So this derivative 3x squared minus 21x plus 30, and we're going to set this derivative equal to 0. Well, I can factor out of 3, x squared minus 7x plus 10, so that should be x minus 5, x minus 2. So that means that we have potential maxes and mins at x equals 2 and x equals 5. Those are what we call some of our candidates. That's why it's called the candidates test. So what we would normally do to find a max or min, and I still encourage this, is to use your number line and plug into your derivative. So when you plug in something smaller than 2 into my derivative, so say 0, you get negative and negative, so you get positive. When you plug in something like 3, well, this guy's now negative, but this one's positive, so that means you have a negative derivative value. Plug in something like 6, everything's positive again, you have a positive, so that means that 2 should be a max, and 5 should be a minimum. So from there, if they wanted to know just absolute max, obviously there's no way in heck I'm going to be checking x equals 5 because it's not a maximum, it's definitely a minimum. But with this candidates test, what they really want you to see, so let's say just for example they want an absolute max, let's do that. What are the possible candidates to be the absolute maximum? Well, definitely our local maximum at f of 2, but also when you do absolute max you have to check endpoints as well. They give you a region, you need to be able to check the endpoints. So I'm going to actually have to find f of 0, f of 2, and f of 6. If you found f of 5, that's fine as well. We know it's a minimum. I really shouldn't have to check that. But if you do so, that's not the end of the world. So to find those values, those are function values. Those are y values, meaning you're plugging back into our f of x function. That's the only way that we're going to find a y value. So when you plug in 0, that one's pretty easy, and they're pretty good at doing that, giving you some easy ones. That becomes 1. When you plug in 2, you should find 27. Plugging in 5, well, we said it really didn't matter, but just in case, 13.5 is what happens there, and f of 6 as our other endpoint becomes 19. So this should be really easy now to see what our absolute min, absolute max is. So they wanted the absolute maximum. The absolute maximum is 27. That's the biggest of these y values. They asked as well, when we go back to it, if they asked for absolute minimum, well, we would need to make sure we include the minimum this time. And the absolute minimum, in this case, is the smallest y value here, which is 1. So a lot of people, the answers that would be on a multiple choice question would be giving you 13.5 because that's where the local minimum occurs. But that's not the absolute minimum. Absolute means you got to check these endpoints, have to do this candidates test to find what y value is the biggest and which one is the smallest.